in this problem, they say that the figure below shows the velocity graph for a particle having an initial position x sub 0 equal 0 meters at t sub 0 equals 0 second. At what time or times is the particle found at x equal 35 meters? So what I'm going to do here, I'm going to start my analysis, by describing how is the particle moving. At the same time, I will be able to calculate the position because I have the graph of velocity versus time. So I know that the area under the graph, would be the position. So when you want to find position in a graph like this one, you have that the position at a time t, at whatever time is, right, is equal to the initial position plus the area under the graph of velocity versus time, right? So if I want to find the position at any time, I will just include my initial position plus the area under the graph of velocity versus time. In this case, my initial position is 0 because a sub 0, that is the same that x initial, is 0 at t equals 0 second. So I have 0 meters at t equals 0 second. So this one would be 0. So basically I know now that the position will be the area under the graph of B. Now, at the same time, I want to analyze what is going on in each interval of this graph. So from 0 to 4 seconds, from time equals 0 second to time equals 4 seconds, right? The velocity of the particle is increasing. Okay? You agree? Of course, right? Why? Because we have this portion of graph here that is increasing. Now, at t equals 4 seconds, the particle is what is going to be its position. I will find the area under this portion of the graph, right? I will find the area under this portion of the graph. So that area here is a triangle, so it's 1/2, where we have 10 meters per second minus 0 meters per second, right? This is the variation in velocity times, then the base of the triangle will be 4 seconds minus 0 seconds. So what is going to be this? This would be 20 meters, right? So the particle is 20 meters, 20 meters away from the starting point, okay? It's 20 meters away from the starting point. Now, what happens after that? We see how we reach the highest velocity here, and then the velocity is going to start to decrease in this region, right? The velocity decrease in this region over here. So now I know that from t equals 4 seconds to t equals 8 seconds, the velocity of the particle decreases. Here, I forgot in the first paragraph, of course, to say that increases, right? So from t equals 0 to 4, the velocity of the particle is increasing. And at t equals 4 seconds, the particle is 20 meters, from the origin. Now, from t equals 4 seconds to 8 seconds, the velocity of the particle decreases, right? Decrease. And then we're gonna find the area under the graph. When we find the area under this graph, now we have that x is equal 1/2, Of course, we have an initial position now in this second part, okay? We have now an initial position. There is 20 meters, right? So we have already these 20 meters, but let us find now, we want to find where it is at x equal 35 meters. So I'm going to do something. I will find the area from 4 to 6, right? And that area from 4 to 6 seconds, okay, include the area of this square and the area of this triangle. Okay, so I can just using the area of the square and the area of the triangle, find this area in this region, So I hope that it's gonna be 35 meters just before 8 seconds, because as this graph is symmetric, at t equal 8 seconds, it would be 40 meters from the initial point, right? So it will be 35 meters from the initial point, before t equals 8 seconds. So I will just find what is the value when t is equal to 6 seconds. So I'm going to say that in this case, I have the initial 20 meters plus the area under the graph in this second portion of the graph from 4 to 6, where I have what? I have this area, that is the area of the square. There is, in this case, 5 meters per second minus 0 meters per second times, 6 seconds minus 4 seconds plus, and then the area of this triangle, that is 1/2. Then now we have 10 meters per second minus 5 meters per second times, then 6 seconds minus 4 seconds. Right? So 5 minus 0 will be 5, 6 minus 4 will be 2, 5 times 2, of course, will be 10. So this here is 10 meters. And then here again, we have 10 minus 5, 5, 6 minus 4 is 2, 5 times 2, 10 divided by 2 is 5. So these are 5 more meters. So x equals here 20 meters plus 10 meters plus 5 meters. So this would be 35 meters from the origin. So now I know, that at t equals 6 seconds, and let me just fix here because I just did this analysis, only from 4 to 6 seconds. Now I know that at t equals 6 seconds, the particle is 35 meters from its origin. Now, what happens in 2 more seconds, just to finish, describing what is happening in this graph. In 2 more seconds, the particle is going to stop, right? So at t equals 8, we have, that the particle is going to stop, and this is what is called a turning point, because the direction of the velocity is going to change. And then now we have that in this region over here, the velocity start to increase again. But in opposite direction, by going in opposite direction. Right? So what we have from 0 to 4, the velocity increasing. At t equal 4 seconds, my particle is 20 meters from the origin. At t equal 4 seconds, my particle reach its highest velocity, its maximum velocity. After 4 seconds, the velocity starts decreasing, right? So that at t equals 8 seconds, the velocity is 0. And then there is a variation, there is a change in the direction. So we have here a turning point, so the turning point is always where the velocity of the particle turns 0, and then the direction of the velocity just change, right? I had a positive velocity here to the left of t equals 8 seconds. I have a negative velocity to the right of t equals 8 seconds. So at t equals 8 seconds, I have a turning point, right? And then after that turning point, we have that the velocity starts to increase again, but now with the particle going in opposite direction. Now, where was, or at what time was the particle 35 meters from the origin? At 6 seconds, the particle was 35 meters from its origin. So this is a complete analysis, right, of this graph. This is the simplest way to do the analysis, okay? And with this analysis, we found, based on, the fact that the position is the area under the graph of velocity, the position of the particle at a given time. So we determine the time at what the particle was on a specific position. Okay? Any question?